welcome to lecture number 18 of fuzzy sets, logic and systems and applications. So, this lecture we will discuss the distance between two fuzzy sets, which is in continuation to our previous lecture, lecture number 17, where we have discussed how to find the distance between two fuzzy sets A and B. So, if we look at the fuzzy sets that we have taken, these fuzzy sets were two discrete fuzzy sets A and B, and this is how we had plotted these two discrete fuzzy sets A and B. And in the previous lecture, we also saw as to how we can tabulate the values of delta x A, x B, mu A of x A, mu B of x B, and then we took minimum of the two, that means minimum of mu A of x A and mu B of x B. So, when we have found the minimum of mu A x A and mu B x B, we, with respect to the previous example, we found two values of minimum of mu A x A comma mu B of x B, which were 0.4 and 0.3. So, in the last column of this table, we had to take the maximum of these values. So, here we have two values 0.4, 0.3. When we take the maximum of these two values, we get 0.4. So, this 0.4 is with respect to the delta value, which is 0, which was taken 0, and correspondingly we have taken the x A, x B values. Similarly, now we will move ahead and we will try to find if we have any such combinations which are leading to delta is equal to 1. It may be possible that we may not find any such pairs for which delta is equal to 1, and if this is the case, then we will move ahead and we will try to find the pairs for which we get delta is equal to 2. And this way we will keep moving ahead till the highest value for which the x A, x B pairs we are getting the highest value of delta. All right. So, let us now quickly try for delta is equal to 1, which is here. So, if we start finding the x A, x B values from these two discrete fuzzy sets A and B, which are given. So, we see that we have 4 such combinations. We have one from fuzzy set A, which is here, and 2 from fuzzy set B, and then we have another element, another pair 2, 3, and this 2 is from fuzzy set A, and here we have 3, which is from fuzzy set B. Similarly, we have 3, 2 as the third element, 3 is from discrete fuzzy set A and 2 is from the discrete fuzzy set B. And the fourth pair here is 3, 4. So, all these 4 pairs are resulting delta is equal to 1. No other pair is going to result us delta is equal to 1. So, these pairs should be drawn from discrete fuzzy set A and B, which is given in the example. So, let us now use these pairs for lambda is equal to 1 and tabulate the values of x A, x B, mu A x A, mu B x B, and then we take minimum of all these findings, and then finally, we take max, and let us see how does it go. So, for the first pair 1 2, which you see here, it is encircled here, and we write here delta is equal to 1. So, for this delta is equal to 1, which is in the first column. So, please look at the first column here, first column of the table, where we have entered in delta column, which is first column of the table 1, and then let us tabulate all the corresponding entries with respect to delta is equal to 1. So, first entry here will be for the pair 1 2. So, when we take 1 2, we write here as this is x A 1, and then we have 2 as x 1 b. This signifies that this is the first generic variable of the discrete fuzzy set A, and x 1 b signifies the generic variable value, which is from the fuzzy set B. Similarly, all other values can be understood. Now, here enter in the second column, which is x A, we enter 1, and for x B we enter 2 here, and then let us find from the a discrete fuzzy set that is given, we have 0.5 with respect to the generic variable value x A here. So, we are getting 0.5, and then we enter here mu b x b or mu b of x b, which is 0.4. Now, in the sixth column here, we take minimum of all these entries, and this gives us 0.4. Now, let us take other pairs for which we are getting delta is equal to 1. So, when we take the second pair, which is 2 3, we are getting, we are first of all we are entering these values 2 3 x A x b, and then we take the mu A x A, mu b x b, and we take the minimum of these two, which is coming out to be 0.4, and that is how we get here 0.4. Next, we take the third pair, and third pair for which delta is equal to 1. So, we have 3 2, we have written here 3 and then 2, and then we have their corresponding membership values, which we are getting from the discrete fuzzy sets A and B. Now, when we take minimum of these two, we are obviously getting 0.3. So, that is how this row is entered, and then we have fourth element 3 4, fourth pair, for which we are getting delta is equal to 1. So, here also we enter 3 4 and then their corresponding membership values, and when we take min of these two entries, we are going to get 0.3. Now, when we have found all four minimum of the corresponding membership values, which are these corresponding to delta is equal to 1, then we take the max of all these. So, here we take max, and then this max is going to give us 0.4. So, now this way we are able to find all these values of x A, x B corresponding membership values and min of all these, and then finally max we are getting 0.4. So, that is how for delta is equal to 1 we have entered all the corresponding values. Now, we will check for delta is equal to 2. So, the delta is equal to 2, let us see how many pairs, how many such pairs we are getting for which we are getting delta is equal to 2. So, here if we see both the discrete fuzzy set we are getting 1 3 and 3 4. So, these two pairs are giving us delta is equal to 2. So, now let us on the same lines enter these values. So, when we take 1 3 we are getting 0.5, 0.4 as their corresponding membership values. When we take min we are getting 0.4 and similarly for the second pair which is 2 4. So, when we take 2 4 we are getting the corresponding membership values 1 and 1. So, this way our all entries with respect to the delta is equal to 2 are complete. And then when we take max we are getting 1, of course, this the max of these two are 1. Next, let us try to find all the pairs for which delta is equal to 3. So, this delta is equal to 3 we get only one such pair, and when we use these values 1 4 as the pair elements. So, 1 4 for delta is equal to 3 and then the corresponding membership values are entered over here, and when we take minimum of these we are getting 0.5, and since we have only one entry here. So, maximum of this is going to be 0.5. So, this will be 0.5. So, now we understood as to how we fill this table for which is going to help us in finding or making the fuzzy set which is giving us the distance between two discrete fuzzy sets A and B. So, now we can use this delta. When this table is complete, we use this table, we pick all the delta values and we pick all the mu d a b values, mu d a comma b of delta values. So, when we take these two entries, the delta entries and corresponding membership values. So, these two, the first column and the last column. So, we see that when we take 0 as delta, so delta is equal to 0 is going to give us mu d a comma b of delta 0.4. Similarly, if we take delta is equal to 0, we are getting mu d a comma b delta 0.4. Similarly, for 2 delta is equal to 2, delta is equal to 3, we get its corresponding mu d a comma b delta. And when we use these entries, because one is the generic variable value which is delta, which is nothing but the difference as we have already discussed, because delta is the difference between the corresponding generic variable values of the two fuzzy sets A and B, and then the last column gives us its corresponding membership values. So, we can make use of these two entries and we can construct here a fuzzy set which is mentioned by d of AB is equal to 0.4 oblique 0, means at generic variable value 0, which is the difference, that is delta is equal to 0, this is delta is equal to 0, and for this delta is equal to 0, we are getting here 0.4 as its corresponding membership value. Similarly, here we are getting another element as 0.4 oblique 1. So, we see that delta is equal to 1, we are getting 0.4 as its corresponding membership value. And then for delta is equal to 2, we are getting 1, and similarly for delta is equal to 3, we are getting its corresponding membership 0.5. So, this is how we are making use of this table and we are constructing a fuzzy set, which is nothing but the distance between the fuzzy sets A and B, which is represented by D of A comma B, which is this. Now, let us plot this fuzzy set, and if we make use of these values here, its elements, we can very easily plot or find the fuzzy set, which is nothing but the distance between the two fuzzy sets. So, here we can clearly see that this is delta, this x axis here is delta, and the y axis, the ordinate here is the membership grade, that is mu of delta. So, at 0 we have its corresponding membership as 0.4, which is here, and at 1 also we have 0.4, which is here, this level, and then at 2 we have 1, which is here, and at 3 we have 0.5, see here 0.5, this 0.5. So, this way we are able to find the fuzzy distance between two discrete fuzzy sets. So, here we have just to help you, we have included the MATLAB code for finding the distance between two discrete fuzzy sets A and B. So, you can make use of this MATLAB code to find the distance between any two discrete fuzzy sets. Now, let us find the distance between B and A, and this way we will try to verify whether distance between two fuzzy sets A and B, whether this is equal to the distance between two fuzzy sets B and A. So, this is a very interesting example which will show us that these two distances, the distance, either we find the distance between A and B or B and A, and where these A and B are two fuzzy sets, these two are always equal. So, let us verify this. So, we have fuzzy set A and B. So, let us now find the distance between B and A. So, let us now, for the same example that we have already taken, let us find the distance between fuzzy set B and A. Please note that here we will take B first and then A, and let us now enter all these values in the table, which we have already discussed as to how we can fill up these values. So, here also we will have, because we are taking the same sets, same discrete fuzzy sets A and B. So, obviously, here we are going to have the delta, the difference as 0, 1, 2, 3. So, for all these delta values, let us now enter these values in this table. So, for 0 for delta is equal to 0, again we have 2 pairs. Here we have 2 2 and 3 3, for which we are going to get delta is equal to 0. So, let us now enter this value, this value of delta here, which is 0, and for this 0, for this value of delta which is 0, we are now entering corresponding values of x b and x a. So, when we do that, we are going to get 2 2 0.4 1, and then if we take min of these 2, we are going to get 0.4. Similarly, for 3 3, we are going to get 0.3. Now, as we have already seen in the previous example, mu d of b comma a of delta, we are going to take the max of these two values. So, when we take max of these two values, we are going to get 0.4. Now, here we have completed all the entries for delta is equal to 0. Now, let us do the same for delta is equal to 1. So, when we take delta is equal to 1, we have 4 entries, as we have seen in the previous example also. Here also we have 4 entries, 4 pairs. So, let us now put all these in the table. So, here we will write delta is equal to 1, and the first pair we write 2, 1, and then 0.4, 0.5, and then we take minimum of these two, we are going to get 0.4. And this way we are able to complete the entries for the first pair, for which delta is equal to 1. Now, the next pair we have 3 2. Then the next pair, the third pair, we have 2 3, and then the last pair, which is the fourth pair, we have 4 3. And then we at this stage we know how are we getting these values, these corresponding values of membership, and then we have taken the min of the corresponding membership values of A and B, and then when we take max of these values, we are going to get here 0.4. So, this is 0.4. So, if we look at this, we have completed all the entries corresponding to delta is equal to 1. Now, let us move ahead and fill all the entries corresponding to delta is equal to 2. So, when we apply the same logic, we have 2 pairs for here for delta is equal to 2. One is the 3 1 and the second one is the 4 2. So, here we will write all the entries in the table, and when we again take the maximum of this, we are going to get 1, which is mentioned over here. Now, next when we move to delta is equal to 3. So, we see that we have only one pair for which we are getting delta is equal to 3. So, we fill the table with delta is equal to 3 and its corresponding values. So, here since we have only one value, we take max, we get only 0.5. Now, please note that we do not have any pair for which we get delta is equal to 4. So, we will stop here. And then again, as we have done in the previous example, we take the first column, which is delta column, and the second column, which is the mu d b comma a delta. So, here we will take these two columns, we will make use of these two entries, and we will write the fuzzy set, which will be representing the distance between two fuzzy sets B and A. So, when we make use of these entries, here we are going to write d b comma a. This is nothing but the distance between the fuzzy set, discrete fuzzy set A B and A. In earlier case, we had the distance between the fuzzy set A and B. So, the difference here is that we have changed the sequence. So, here we are taking B first, the fuzzy set B first, and then A. So, d b comma A represents the distance between fuzzy set B and A, and which is nothing but the 0.4 oblique 1. So, 0.4 is the mu corresponding to delta, and this delta here is 0, this delta here is 0. So, for delta is equal to 0, which we can see in the very first column, we have all the delta values mentioned. We have delta is equal to 0, 1, 2, 3, and then when we take the corresponding membership values, which are mentioned in the last column. So, we have for delta is equal to 1, we are getting 0.4. So, this 0.4 is from here, and then for delta is equal to 1, we are getting the corresponding membership value from here, and then similarly for delta is equal to 2, we are getting the corresponding membership value here. Similarly, for delta is equal to 3, we are getting the corresponding membership. So, this way we have got a fuzzy set, which is nothing but the distance between discrete fuzzy set B and discrete fuzzy set A. And when we plot these fuzzy set, we are going to get here a fuzzy set which is exactly same as the fuzzy set as the distance between fuzzy set A and B we have got in the previous example. So, we can clearly see here that whether we calculate the distance between A and B fuzzy sets or B and A, both are same. So, we can clearly see here, if we plot or even the values also, we see that d A comma B is same as d B comma A. So, this way we can say that we have verified that d of A comma B is equal to d of B comma A. So, this means that the distance between fuzzy sets A and B is exactly same as the distance between fuzzy sets B and A. So, by now we have understood very clearly as to how we can find the distance between any two fuzzy sets. So, if we can manage to find these entries here, first the delta value, the difference. So, we will first find all the possible values of the delta from the given fuzzy set. like we have seen in this example, and then we find all such pairs for which we are getting the different delta values. So, these pairs will be used to find their corresponding membership values, and these values then we will fill in the table as x b x a, mu b x p, mu a x a, and then we take the minimum of these values, these membership values, and then when we have done for all such pairs, all the minimum values are found out, then we take max of these values to get the final value, which is mu d b comma a of delta. So, this way we can manage to get all the entries, all the values of delta and its corresponding membership values. And these two values delta and mu of delta will help us in constructing the fuzzy set, the discrete fuzzy set here in this case, because we have taken discrete fuzzy set only, and so the distance between the two discrete fuzzy set is of course obviously going to return us the discrete fuzzy set as the distance between the two discrete fuzzy sets. So, with this I would like to stop here, and in the next lecture I will try to cover few more examples on distance between fuzzy sets. Thank you.